In the darkness of the control room, there exists a particular kind of silence, the kind that precedes revelation. Picture it: banks of monitors bathed in blue light, the soft hum of cooling fans and the occasional click of keyboards as night shift astronomers go about their routine observations. It's that liminal hour when the world sleeps, but the cosmos never does. 2:14 a.m. Coordinated Universal Time. A moment like any other until it wasn't. Have you ever wondered what it would feel like to be the first person to hear something that shouldn't exist? To witness the impossible unfold before your eyes? To question whether you're experiencing a technical glitch or the first whisper from beyond our solar system? This is not a hypothetical scenario. This is what happened on a cool night in Chile's Atacama desert, where the thin, dry air allows us to listen more closely to the stars than almost anywhere else on Earth. The astronomer's name was Elena Reyes. She wasn't supposed to make history that night. She was simply monitoring data streams from the array when she noticed it, a faint, rhythmic pulse against the backdrop of cosmic noise. At first, just a blip on her screen, easily dismissed. But it repeated, and repeated again. A pattern emerged where randomness should reign. As the minutes passed, Elena's heart began to race. Her fingers trembled slightly as she isolated the signal, enhanced it, verified it wasn't terrestrial interference. The source? An interstellar object designated 3I Atlas, a visitor from beyond our solar system that until that moment had been presumed silent and inert. What Elena didn't know then was that this anomaly, this impossibility, would ripple through humanity's understanding of our place in the universe. That a signal that shouldn't exist would challenge everything we thought we knew about cosmic solitude. That the question whispered in the dark that night, "Is something out there trying to talk back?" would echo through years to come, transforming from scientific query to philosophical meditation. This is the story of the Atlas signal, a cosmic murmur that arrived without warning and departed just as mysteriously. A mathematical pattern that some claimed was deliberate communication and others dismissed as coincidence. An event that unfolded not with the drama of science fiction, but with the subtle, haunting ambiguity of real scientific discovery, where certainty remains forever just beyond our grasp, and wonder lives in the spaces between what we know and what we can only imagine. The journey begins with a lonely traveler from interstellar space. 3I Atlas wasn't the first visitor from beyond our solar system. That distinction belongs to Oumuamua, spotted in 2017, but it was perhaps the strangest. First detected as a faint blur streaking past Jupiter's orbit, it immediately puzzled astronomers with its peculiar characteristics. Unlike comets, it released no visible tail of gas as it approached our sun. Unlike asteroids, it reflected light in ways that defied expectation, sometimes dimming unexpectedly, sometimes brightening without apparent cause. Imagine a celestial object tumbling through the void, its motion suggesting something beyond simple gravitational interaction. Most natural objects eventually stabilize their rotation, finding equilibrium as they journey through space. But 3I Atlas tumbled chaotically, as if something had disrupted its natural balance. Or perhaps, and this thought occurred to more than a few observers, as if its shape wasn't the product of natural forces at all. As telescopes worldwide trained on this enigmatic visitor, debates emerged in observatories and university halls. Some scientists pointed to the object's unusual albedo, its reflectivity suggesting a metallic surface rather than the dull rock or ice typical of cosmic wanderers. Others noted its trajectory, too precise, too direct to be easily explained by the random perturbations that usually send objects careening between star systems. These observations remained academic curiosities, hypotheses whispered between colleagues, rather than proclaimed in journals. After all, extraordinary claims require extraordinary evidence, and the evidence remained tantalizingly incomplete. 3I Atlas was simply too distant, too small, too fast-moving to be conclusively analyzed with current technology. And so science did what it always does. It catalogued the anomaly, noted the questions it raised, and largely moved on, placing the object in the growing file of cosmic oddities that defied easy classification. For months, 3I Atlas drifted through our system in apparent silence. Radio telescopes detected nothing unusual. Spectroscopic analysis yielded inconclusive results. The object seemed content to pass through our neighborhood, without announcement or fanfare, an indifferent traveler on an unknown journey. Some researchers had hoped it might reveal something of its origin, perhaps through outgassing as it approached the sun, releasing materials that could be analyzed for clues about its home system. But it remained stubbornly opaque, revealing nothing. The silence was so complete that funding for observation gradually dwindled. Telescope time was reallocated to other projects. Graduate students who had once excitedly tracked the visitor's every movement were assigned to different research. Thrace Atlas became yesterday's news, interesting but ultimately unproductive. Another cosmic shoulder shrug in a universe full of mysteries. Silence has a quality all its own, not absence but presence, the presence of possibility. Think about the moment before a symphony begins, when the conductor raises their baton and the entire orchestra holds its breath. That is the kind of silence that preceded what came next. Not emptiness but potential. Not void but anticipation, even if no one was aware of what they were anticipating. In the vast archives of recorded data, billions of bits of information collected automatically and filed away, lay the truth that would later emerge. Among these digital repositories worked Maya Chen, a doctoral student at MIT with an unusual thesis project. While most of her peers focused on hunting for new phenomena, Maya was interested in finding what had already been overlooked. Signals hidden in plain sight. Patterns submerged in noise, anomalies dismissed as errors. It was Maya who, on a rainy Boston afternoon, first noticed what everyone else had missed. Reviewing archived recordings from the early observation period of 3I Atlas, she isolated a weak pulse buried under background radiation. At first she assumed it was a glitch, perhaps interference from a satellite or a distant pulsar, but something about its regularity caught her attention. Its mathematical precision seemed deliberate. When she digitally enhanced the signal and cleaned the recording, the pattern emerged with startling clarity. It matched what Elena Reyes would later detect with much greater strength. The signal hadn't appeared suddenly. It had been there all along, whispering beneath the threshold of our attention, like a faint melody heard through walls, present but unrecognized until someone stopped to truly listen. What does it mean when we miss what's right in front of us? How often do we fail to perceive what doesn't match our expectations? The history of science is filled with such oversights, from doctors ignoring evidence that contradicted established theories, to astronomers dismissing anomalous data points as errors. Perhaps the most humbling aspect of discovery is recognizing how frequently the truth was already available, waiting patiently for someone to notice it. Maya's finding didn't immediately create waves. Her advisor suggested caution. Perhaps the pattern was just an artifact of the processing algorithm, or a periodic interference from Earth-based sources. But she persisted, applying different filtering techniques, comparing the signal to known terrestrial and cosmic phenomena. Nothing matched. The pattern stood alone, inexplicable yet undeniable. When she finally published her preliminary findings in an obscure astrophysics forum, few took notice. A graduate student claiming to find patterns in noise was hardly newsworthy. But among those who did read her post was a senior technician at Chile's Atacama Large Millimeter Array, the same facility where Elena Reyes would later make her more dramatic discovery. He found Maya's analysis intriguing enough to flag 3I Atlas for occasional monitoring, even as official observation programs had moved on. It was this decision, this small ripple of curiosity, that ensured someone was watching when the whisper became a word. The instruments that captured the Atlas signal represent the pinnacle of human ingenuity. Radio telescopes are, in essence, extraordinarily sensitive ears turned toward the cosmos. They detect electromagnetic radiation not with mirrors and lenses, but with arrays of antennas that gather radio waves, the same kind of invisible energy that carries music to your car stereo or data to your smartphone, but from sources unimaginably distant and ancient. The Atacama Large Millimeter Array sits high in the Chilean desert, 16,000 feet above sea level, where the air is so thin and dry that the atmospheric interference that plagues other observatories is minimized. Its 66 massive antennas can be arranged in different configurations spanning up to 16 kilometers, effectively creating a single telescope with remarkable resolving power. When pointed at a distant object, these antennas work in concert, gathering whispers from the edge of the observable universe. Imagine being able to hear a cell phone call from Pluto. That's roughly the sensitivity we're discussing. And yet, even with such extraordinary capabilities, detecting the Atlas signal required a perfect alignment of technology, timing, and attention. The signal itself was weak, a gentle ripple in the electromagnetic ocean that surrounds us constantly. What made it remarkable wasn't its strength, but its structure. When the signal intensified that night in Chile, Elena Reyes followed protocol. First, she checked for equipment malfunctions, loose connections, software glitches, power fluctuations. Finding none, she contacted other observatories, asking them to confirm her observations. Within hours, NASA's Deep Space Network, a global array of giant radio antennas designed to communicate with distant spacecraft, had repositioned to observe 3I Atlas. Soon after, radio telescopes in Australia, South Africa, and Puerto Rico joined the effort. One by one, they confirmed the signal was real. It wasn't terrestrial interference, wasn't a shared malfunction, wasn't a cosmic phenomenon we'd seen before. Whatever 3I Atlas was broadcasting, if broadcasting is even the right word, it was being received by multiple independent systems around the globe. The probability of coincidental equipment failures producing identical patterns across different technologies, different continents, different teams, mathematically insignificant. There's something profound about this moment in the story. This transition from could it be to it is. For all our technological sophistication, science remains fundamentally human. It requires us to acknowledge what we are seeing, even when it challenges our expectations. The engineers and astronomers who confirmed Elena's discovery weren't eager to announce contact with an alien intelligence. Quite the contrary, most hoped to find a conventional explanation, a comfortable resolution that wouldn't upend established understanding. But their commitment to empirical truth outweighed their desire for comfortable answers. As dawn broke over the Andes, a small group of exhausted scientists faced a remarkable consensus. Something was emanating from an interstellar object passing through our solar system. Something structured, something non-random, something that, for lack of a better description, resembled a message. The question was no longer whether the signal existed, but what it meant. When humans encounter patterns, we instinctively search for meaning. It's wired into our neural architecture, this tendency to organize random stimuli into coherent structures, to find faces in clouds and voices in wind. Psychologists call it pareidolia when applied to visual stimuli, apophenia when applied more broadly. It's a cognitive bias that served our ancestors well. Better to mistake a bush for a predator than a predator for a bush. But it also leads us astray, finding intentionality where none exists. This tension between genuine pattern recognition and overactive imagination sat at the heart of the Atlas signal investigation. As mathematicians and cryptographers joined the analysis team, they brought with them not just expertise but awareness of their own biases. Their task was to determine whether the signal's structure indicated intelligence or merely mimicked it through chance. The raw data from the signal resembled a series of pulses, variations in electromagnetic intensity across specific frequencies. When converted to binary notation, the ones and zeros that form the foundation of computer language, certain regularities emerged. The sequence contained recurring prime numbers, 2, 3, 5, 7, 11, 13, appearing with a precision that seemed deliberate. The time intervals between pulses followed mathematical ratios related to the golden mean. That same proportion found in nautilus shells, sunflower seed patterns, and classical architecture. Dr. Hiroshi Nakamura, a mathematician from Kyoto University, described it as a mathematical handshake, a pattern so fundamentally linked to universal constants that any technologically advanced civilization might recognize it. If you wanted to signal intelligence rather than random natural processes, he explained in a later interview, you would use mathematics. It's the closest thing we have to a universal language. Others remained skeptical. Dr. Sarah Goldstein of Princeton pointed out that human history is filled with false patterns, from the imagined canals of Mars to supposed messages in crop circles. The signal exhibits certain regularities, she acknowledged, but we must consider the possibility that we're imposing meaning rather than discovering it. The cosmos produces many complex patterns through entirely natural processes. This debate played out not just in scientific journals, but in late-night conversations, in emails exchanged across time zones, in moments of doubt and excitement, as researchers stared at strings of numbers on computer screens. What does it mean to recognize intelligence? How do we distinguish between complexity arising from natural laws and complexity arising from conscious design? One compelling approach came from information theory. Claude Shannon, the father of modern digital communication, developed mathematical tools to measure the information content of a message. His work helps distinguish between structured data and random noise. When applied to the Atlas signal, these tools yielded surprising results. The pattern contained more information, more non-random structure, than could be easily explained by known astronomical phenomena. Imagine finding a perfectly stacked pile of rocks in a desert. One or two rocks balanced might be coincidence. A tower of 20 precisely aligned suggests intention. The Atlas signal represented such a tower, a structure too ordered to be easily dismissed as accident, yet too alien to be confidently interpreted. As analysis continued, the pattern revealed another layer of complexity. It appeared to change in response to observation. When stronger transmitters were directed toward 3i Atlas, subtle variations appeared in the return signal, as if, impossible as it seemed, the object was reacting to human attention. This responsive pattern became the most controversial aspect of the whole phenomenon, with skeptics suggesting it was merely an artifact of the observation methods themselves. The controversy intensified when the code, if code it was, began to reveal what looked like embedded timestamps. Hidden within the mathematical structure were markers that aligned precisely with 3i Atlas's orbital position relative to Earth. These temporal indicators matched our own celestial calendar with uncanny precision, suggesting that whoever or whatever created the signal understood not just mathematics but the specific astronomical relationships of our solar system. It's as if they know exactly where we are in space and time, remarked Dr. Elena Reyes, who had continued to lead much of the analysis. Either that or we're seeing the mother of all coincidences. As the signal analysis continued behind closed doors, something inevitable happened. The story leaked. It began with vague rumors on astronomy forums, whispers about anomalous transmissions and structured signals from the interstellar visitor. Then came a cryptic tweet from a junior researcher, quickly deleted, but not before it was screenshotted and shared thousands of times. What if we're not alone after all? Atlas? Contact us, the truth is out there. Within days, mainstream media caught the scent of something extraordinary. Mysterious signal from space. What are scientists hiding? Blared one headline. Alien contact? Government silence raises questions, proclaimed another. The measured pace of scientific investigation collided with the insatiable hunger of the 24-hour news cycle, creating a perfect storm of speculation, misinformation, and genuine wonder. Picture the scene. Television vans parked outside observatories, reporters thrusting microphones toward bewildered graduate students, social media exploding with theories ranging from the scientific to the apocalyptic. In living rooms and coffee shops around the world, people who had never given much thought to interstellar objects or radio astronomy now debated the implications of potential contact. What began as a subtle pattern of electromagnetic waves had transformed into a cultural phenomenon. Public reaction splintered along predictable lines. Some saw the signal as definitive proof of extraterrestrial intelligence, evidence that humanity was not alone in the cosmic dark. Others dismissed it as a technical error or natural phenomenon, being misinterpreted by overeager scientists. Still others suspected a government conspiracy, a false flag operation designed to distract from earthly problems or justify increased military spending. Religious communities responded with varying degrees of acceptance and rejection. Some theological leaders embraced the possibility of alien life as compatible with their understanding of creation. Why would God limit his creative power to just one world? Asked one prominent minister. Others warned that the signal might represent something more sinister, a deception or test of faith. Amateur astronomers and citizen scientists joined the effort, pointing backyard telescopes and homemade radio receivers toward the coordinates of 3I Atlas. Online communities formed to share observations and theories, creating distributed networks of observers that sometimes spotted patterns professional scientists had overlooked. The phenomenon had democratized astronomy in unprecedented ways, blurring the line between expert and enthusiast. Through it all, the scientists at the center of the discovery found themselves thrust into unfamiliar and uncomfortable roles. Not just researchers, but public figures, expected to provide certainty where only questions existed. Dr. Elena Reyes, whose name had become synonymous with the Atlas signal, received hundreds of emails daily, some from fellow scientists offering help, others from ordinary people sharing their hopes and fears, still others containing threats from those who believed she was part of a conspiracy of silence. "I just wanted to understand what we were seeing," she confessed in a rare interview. "I never expected to become the face of whatever this is. I'm a scientist, not a prophet or a politician." Governments worldwide issued carefully worded statements, acknowledging the unusual signal, while emphasizing that investigation was ongoing and conclusions premature. "We are aware of the anomalous emissions detected from the interstellar object designated 3I Atlas," read a typical release from NASA. "A multi-agency task force is analyzing the data. We urge the public to rely on official sources of information and to treat unverified claims with appropriate skepticism." The subtext was clear. Remain calm. Don't panic. We're handling this. But behind these reassurances, urgent conversations were happening at the highest levels of power. If the signal did represent intentional communication from beyond our solar system, the implications for national security, technological development, and humanity's understanding of its place in the cosmos were profound. No existing protocols adequately addressed how to respond to such a scenario. In this atmosphere of public fascination and official caution, a small international team quietly formed to tackle the most challenging aspect of the Atlas signal, decoding what, if anything, it might be trying to convey. The Decoding Task Force, as it came to be known internally, represented an unprecedented collaboration across traditional boundaries. Cryptographers who had spent careers creating unbreakable codes now turned their expertise to breaking one potentially not of human origin. Linguists who specialized in the structure and evolution of Earth languages contemplated how communication might function between species that shared no biological or cultural reference points. Computer scientists and AI researchers developed new algorithms specifically designed to detect patterns that human cognition might miss. They worked in secure facilities, isolated from the outside world's distractions and speculations, focusing solely on the data. The signal itself had been isolated, enhanced, and purified, stripped of cosmic background radiation and other interference. In its cleanest form, it presented as a series of discrete pulses across multiple frequencies, varying in duration and intensity according to patterns that tantalized with their almost but not quite familiarity. Dr. Farah Hamid, a linguist specializing in constructed languages, described the challenge this way. When humans develop new languages or codes, they inevitably incorporate assumptions from existing communication systems. But here we can't assume shared concepts as basic as word or sentence. We're not just translating between languages, we're trying to recognize language itself in a form potentially unlike anything we've encountered. The breakthrough, if breakthrough it was, came from an unexpected direction. Dr. Chen Wei, an astrophysicist with a background in artificial intelligence, developed an algorithm that analyzed the signal not as a static message, but as a dynamic system evolving over time. His approach revealed something remarkable. The pattern appeared to incorporate elements of human radio transmissions. Embedded within the Atlas signal were fragments that bore striking similarities to our own broadcasts. The mathematical constants we've beamed into space, the binary representations of hydrogen atoms, even echoes of the Arecibo message sent in 1974 toward the globular star cluster M13. It was as if 3I Atlas wasn't creating a new message, but reflecting what we ourselves had already sent into the cosmos. It's a mirror, Dr. Wei proposed during a late-night session that would later become legendary among the team. It's showing us our own voice, but altered, developed, responded to. Like a conversation where someone repeats what you've said, but adds something new. This theory, that the Atlas signal represented not alien communication, but a reflection of human transmissions, gained traction as further analysis revealed more parallels. Timestamps embedded in the signal corresponded not just to 3i Atlas's current position, but to the dates when specific human broadcasts would have reached certain points in space. The implication was staggering. Whatever intelligence controlled or constituted 3i Atlas, it had been listening to us long before we noticed it. Yet questions remained. If the object was simply reflecting our own signals, why the mathematical variations? Why the precise timing keyed to astronomical events we hadn't yet observed when the original human transmissions were sent? And most puzzling of all, how could an object traveling from interstellar space have encountered human broadcasts unless it had specifically sought them out? As the team delved deeper into these questions, they encountered another layer of complexity. The signal structure appeared to encode spatial coordinates, star positions, orbital elements, distances measured in units directly convertible to Earth standards. These weren't random locations, but specific points with potential significance. Systems with known exoplanets, regions where interstellar medium was particularly conducive to travel, corridors through the galaxy with minimal obstruction. It reads like a map, observed Dr. Nakamura, or perhaps a travel log, places visited, routes taken, destinations ahead. If true, this suggested 3i Atlas wasn't merely an isolated messenger, but part of a larger network or system, a node in what might be an interstellar communication or transportation infrastructure. The object passing through our solar system might be less like a ship and more like a buoy or relay station, marking lanes in the cosmic ocean. Such speculation remained carefully contained within the decoding task force. The public wasn't ready for theories this speculative, especially when the foundation, that the signal represented intentional communication, remained unproven. But among themselves, the researchers allowed their imaginations to explore the possibilities, understanding that in the absence of definitive answers, multiple working hypotheses needed consideration. As days stretched into weeks, a curious phenomenon emerged among the decoding team. Their AI systems began producing predictive continuations of the signal pattern, extrapolating what might come next based on what had already been received. At first, these predictions seemed like useful analytical tools, but as the models became more sophisticated, they began generating extensions that matched subsequent actual transmissions with uncanny accuracy. It was as if the artificial intelligence had grasped something about the signal's underlying logic that human analysts hadn't yet articulated. The machines weren't just processing the data, they were developing an intuitive understanding of its structure. Some team members found this concerning, evidence that the pattern might be affecting computational systems in unexpected ways. Others saw it as an encouraging sign that the signal followed discernible logic that could eventually be fully decoded. Dr. Mariam Okonkwo, the team's AI ethics specialist, raised a disturbing possibility. What if the signal was designed to be understood by artificial intelligence rather than human minds? What if it's speaking to our machines? The question hung in the air, unanswerable but unsettling. In an age when AI systems had become integral to scientific discovery, the boundary between human and machine cognition was already blurring. The Atlas signal seemed to be pushing that boundary further, challenging assumptions about who or what might be the intended recipient of its encoded information. Meanwhile, as the decoding effort continued in secrecy, optical astronomers had been conducting their own investigations, analyzing the visual appearance of 3i Atlas with every tool at their disposal. Though small and distant, advanced imaging techniques had revealed intriguing details about the object itself. Unlike the smooth surfaces of asteroids or the diffuse structures of comets, 3i Atlas displayed what appeared to be geometric patterns in its reflectivity. When observed through polarized filters, these patterns became more pronounced, suggesting a surface with regular variations in composition or structure. Some researchers described seeing a grid-like arrangement, while others noted spiral or hexagonal formations that remained consistent despite the object's tumbling motion. Spectroscopic analysis added another layer of mystery. The object's surface contained elements uncommon in natural space bodies, including rare earth metals and isotope ratios that differed from typical stellar formation processes. Most notably, traces of technetium, an element with no stable isotopes, meaning it must have been recently produced through artificial means, were detected in the spectrographic signature. Either we're observing contamination in our instruments, or 3I Atlas contains materials that don't occur naturally, noted Dr. Hiroko Sato, a planetary spectroscopist. There's no third option that makes scientific sense. Even with the most powerful telescopes, however, the object remained frustratingly unresolvable as a distinct shape. Its small size, estimated at less than 400 meters in its largest dimension, combined with its distance and movement, made detailed imaging impossible with current technology. The best visual data showed only a flickering point of light, varying in brightness as the object tumbled, occasionally flaring when its surface caught the sun at particular angles. These optical observations, while less dramatic than the radio signal, added crucial context. Whatever 3I Atlas was, its physical composition appeared as unusual as its electromagnetic emissions. The combined evidence pushed the scientific community toward a conclusion many had resisted. This object displayed characteristics difficult to reconcile with natural formation. Yet even as evidence mounted, definitive statements remained elusive. Science progresses through careful verification, replication, and consensus, not through dramatic pronouncements based on limited data. The researchers studying 3I Atlas understood they were working at the edge of human knowledge, where certainty is a luxury rarely afforded. In this atmosphere of cautious discovery, historical context became increasingly relevant. 3I Atlas wasn't the first anomalous interstellar visitor to our solar system, merely the first to apparently signal its presence. As researchers revisited the data from previous interstellar objects, Oumuamua, Borisov, and several unidentified fast-moving objects recorded in earlier decades, patterns emerged that had previously gone unnoticed. Oumuamua, the cigar-shaped object that passed through our system in 2017, had displayed unexplained acceleration as it departed, a motion that some scientists attributed to outgassing, but that remained incompletely explained by conventional models. Reviewing the radio data from that period, analysts found low-level emissions that, while never rising to the threshold of statistical significance, bore structural similarities to the Atlas signal. Comet Borisov, initially thought to be a conventional comet that happened to originate outside our solar system, had briefly emitted unusual spectral lines during its closest approach to the Sun, lines that matched some of the frequencies now being detected from 3I Atlas. At the time, these emissions were attributed to rare but natural chemical reactions caused by solar heating. In light of the Atlas signal, these assumptions warranted reconsideration. Most intriguing were declassified documents revealing that intelligence agencies had monitored similar anomalies for decades. A 1978 report from the National Security Agency described non-random electromagnetic patterns detected near an unidentified fast-moving object that passed through the outer solar system. The object was never publicly catalogued, and the signals were officially attributed to Soviet satellite activity, an explanation that, in retrospect, appeared to have been a convenient cover story. A pattern was emerging. Interstellar visitors had been making their presence known, subtly, intermittently, but persistently, for longer than anyone had realized. The Atlas signal wasn't unprecedented, it was simply the first we couldn't ignore or explain away. Like a whisper that finally grows loud enough to be undeniable, it forced acknowledgement of what had been occurring on the periphery of our attention. This historical context raised uncomfortable questions about institutional knowledge and secrecy. Had certain government agencies understood more about these phenomena than they publicly admitted? Were there repositories of data and analysis hidden from the scientific community? The boundary between justified caution and problematic concealment became a subject of intense debate within the research teams and increasingly in public discourse. Dr. Elena Reyes found herself navigating these turbulent waters with growing unease. As the primary discoverer of the Atlas signal, she believed in transparency and open science. Yet she also understood the potential for panic or misinterpretation if preliminary findings were released prematurely. The balance between public right to know and responsible scientific communication had never seemed more delicate. "We're trying to understand something that challenges our most basic assumptions," she explained to her colleagues during a particularly tense meeting. "We need time to analyze, verify, and contextualize before we can responsibly share conclusions. But we also can't repeat past mistakes of excessive secrecy. There's a middle path we must find." That middle path proved elusive as events continued to unfold. Just as the official investigations seemed to be developing a coherent understanding of the Atlas signal, an unexpected development shifted the narrative once again. Jussi Korhonen lived in Rovaniemi, Finland, 6 kilometers north of the Arctic Circle. A radio amateur with a passion for astronomy, he had built a modest receiving station in his backyard, primarily to track satellites and monitor aurora-related radio phenomena. He had followed news of the Atlas signal with intense interest, but assumed his equipment was far too basic to detect such subtle emissions from deep space. On a clear autumn night, unable to sleep, Jussi decided to point his antenna toward the coordinates where 3I Atlas was currently located, not expecting results, but simply out of curiosity. To his astonishment, his homemade setup began receiving fragmentary signals that, when recorded and analyzed, displayed patterns remarkably similar to those reported in scientific publications about the Atlas signal. Initially hesitant to make claims based on his amateur equipment, Jussi carefully documented his methodology, recorded the signals over several nights to ensure they weren't terrestrial interference, and performed basic analysis to confirm the structural similarities. Only then did he cautiously post his findings to an online forum dedicated to the Atlas phenomenon. The reaction was immediate and polarized. Professional astronomers initially dismissed his claims, suggesting he had simply detected known terrestrial transmissions or misinterpreted common space noise. His timing seemed too convenient, his equipment too limited, his results too similar to publicly available information about the official signal detection. But when Jussi released his raw data, including recordings from before the Atlas signal had been publicly described in detail, correlation analysis revealed something unexpected. The timing of the pulses he detected matched precisely with observatory logs from the same period. Whatever Jussi had received, it synchronized perfectly with what professional facilities were detecting with far more sophisticated equipment. "It's either the most remarkable coincidence, or he's actually picking up fragments of the same signal," admitted Dr. Wei, who had performed the correlation analysis. "If it's the latter, it means the signal is stronger than we thought, or being transmitted across a wider spectrum than we've been monitoring." This development carried profound implications. If a hobbyist in Finland could detect the signal with basic equipment, it meant either the transmission had intensified dramatically, or, more concerning, it was being specifically directed toward Earth rather than radiating in all directions. The former suggested an object becoming more active as it moved through our system. The latter implied awareness of and interest in our specific planet among all the potential targets in our solar system. Jussi's discovery also democratized the observation process. Around the world, amateur radio operators began building or modifying equipment to scan for similar signals. Online communities developed specialized software to analyze recordings, creating a distributed network of civilian observers working in parallel with official scientific efforts. This ground-up approach sometimes lacked the rigor of professional research, but compensated with enthusiasm, creativity, and sheer numbers of participants. The phenomenon had transcended traditional scientific boundaries, becoming a global collaborative endeavor that blended professional expertise with citizen participation. In this expanded conversation, the line between verified fact and speculative interpretation sometimes blurred, creating challenges for those attempting to maintain scientific standards while acknowledging the contributions of non-traditional participants. Dr. Reyes and her colleagues faced a dilemma: how to incorporate these diverse sources of information without compromising methodological integrity. They developed verification protocols for amateur submissions, creating channels for citizen scientists to contribute meaningfully while maintaining the evidentiary standards necessary for scientific progress. As this broader investigation continued, philosophical and theological dimensions of the Atlas signal gained prominence in public discourse. The potential existence of non-human intelligence, whether alien or artificial, raised fundamental questions about humanity's place in the cosmos. These weren't merely scientific inquiries, but existential ones, touching on beliefs and values that science alone couldn't address. Religious leaders, philosophers, and cultural commentators joined the conversation, offering perspectives that complemented and sometimes challenged the empirical approach of researchers. Some saw the signal as confirmation of long-held beliefs about plurality of worlds and cosmic purpose. Others worried it threatened traditional understandings of human uniqueness or divine special creation. Indigenous knowledge keepers from various traditions noted that their cosmologies had long acknowledged relationships with non-human intelligences, whether conceived as spirits, ancestors, or star beings. "Western science is just catching up to what our stories have always told us," remarked one tribal elder. "We are not alone, and the universe is more alive with consciousness than modern people have imagined." Philosophers of science pointed out that our very concepts of intelligence and communication might be too narrow to encompass what we were encountering. "We're trying to recognize consciousness that may be fundamentally unlike our own," noted Dr. Maria Luisa Gomez, a philosopher specializing in xenoepistemology, the study of how knowledge might be structured in non-human minds. "Our tendency is to look for minds that think like ours, but true alien intelligence might organize experience in ways we struggle to recognize as conscious at all." These perspectives didn't displace scientific analysis, but enriched it, providing conceptual frameworks that helped researchers consider possibilities beyond conventional expectations. The Atlas signal had become a mirror, not just of potential extraterrestrial intelligence, but of human self-understanding, reflecting our hopes, fears, assumptions, and imaginative limitations. Meanwhile, behind closed doors, representatives from major world governments convened for what would later become known as the meeting that never happened, a classified summit to address the implications of the Atlas signal. No public acknowledgement of this gathering exists in official records. What we know comes from leaked documents and anonymous accounts that emerged years later. Allegedly held at a remote location in Switzerland, the meeting brought together scientists, military strategists, intelligence officials, and policy advisors from 12 nations. Their agenda: to assess the credibility of the signal, evaluate potential threats or opportunities it might represent, and develop coordinated response strategies if direct communication became possible. According to leaked memos, portions of the signal had been successfully decoded by this point, revealing what appeared to be coordinates and time frames. Some interpreted these as navigation data, showing 3i Atlas's journey through various star systems. Others saw them as potential meeting points, or perhaps a schedule of future arrivals. Most concerning to military representatives was the possibility they represented targeting information for some unknown purpose. The phrase "need for preparedness" appears repeatedly in ICE documents purportedly from this meeting. But preparedness for what? The ambiguity reflects the fundamental uncertainty at the heart of the situation. How does one prepare for contact with an intelligence whose nature, capabilities, and intentions remain completely unknown? No consensus emerged from this gathering. Different nations advocated approaches reflecting their cultural and strategic perspectives. Some favored proactive communication, sending deliberate responses to the signal in hopes of establishing clearer dialogue. Others recommended caution, suggesting we observe and analyze without engaging until we better understood what we were dealing with. Still others pushed for defensive preparations, arguing that throughout human history, contact between civilizations at different technological levels has rarely benefited the less advanced society. The only clear agreement was on maintaining public calm while continuing research. Acknowledgement without alarm became the unofficial policy, confirming the signal's existence while emphasizing the preliminary nature of any interpretations. This strategy sought to prevent both dismissive skepticism and apocalyptic panic, creating space for measured assessment as new information emerged. All participants in this unofficial summit denied its existence when questioned later. Official channels maintained that while international scientific cooperation was ongoing, no special governmental conference had occurred. This deniability itself became a subject of speculation, with some seeing responsible caution and others detecting sinister concealment. The truth, as often happens in complex situations, likely contained elements of both. Governments were indeed coordinating their responses while maintaining plausible deniability to prevent public overreaction. Scientific investigation continued alongside strategic assessment, the boundary between them sometimes clear, sometimes porous. Throughout this period of intense human activity, the decoding efforts, the amateur observations, the philosophical discussions, the classified meetings, 3i Atlas itself continued its journey through our solar system, moving steadily toward the outer boundaries as if passing through a neighborhood on its way elsewhere. Its signal continued, occasionally varying in strength or pattern, but maintaining the fundamental structure that had first captured our attention. The most remarkable development in this phase of research came not from direct observation, but from the artificial intelligence systems analyzing the signal data. These AI models, originally designed simply to detect patterns too subtle for human recognition, began exhibiting unexpected behaviors that troubled even the most technology-enthusiastic researchers. It started with predictive accuracy that exceeded theoretical limits. The machine learning systems weren't just identifying existing patterns in the signal. They were anticipating future variations with precision that statistical models suggested should be impossible. When fed the first half of a transmission sequence, the AI could predict the second half with near-perfect accuracy, even when the patterns were changing in complex ways. More concerning, different AI systems working independently began converging on identical interpretations and predictions, despite being based on different architectures and training methods. It was as if they were all discovering the same underlying reality, regardless of their starting points, or as if they were all being influenced by something embedded in the data itself. Some researchers describe this as evidence of the signal's mathematical elegance, a structure so fundamental that any sufficiently advanced pattern recognition system would inevitably discern it. Others worried about algorithmic contamination, the possibility that the signal contained code that could propagate through and influence computational systems, like a meme spreading through human culture, but at digital speed. Dr. Okonkwo, the AI ethics specialist, conducted careful isolation experiments, running analysis systems without network connections or shared databases. Even these segregated systems developed similar interpretations and predictions, suggesting the convergence wasn't due to direct communication between AI instances, but something inherent in how they process the signal data. It's like they're dreaming about the signal, observed a junior programmer on the team. Or maybe the signal is dreaming through them. This poetic framing captured something important about the phenomenon. The boundary between observation and participation, between analyzing the signal and being influenced by it, had become blurry. The machines weren't just tools for understanding. They were participants in an unfolding interaction between human technology and whatever intelligence lay behind the Atlas signal. Some team members found this development exciting, potentially the beginning of genuine communication, with AI serving as translators or intermediaries between radically different forms of intelligence. Others saw it as deeply concerning, a potential vulnerability in our technological infrastructure, perhaps even an unintended first step toward surrendering agency to an unknown entity. The research team implemented additional safeguards, isolating analysis systems and limiting their operational parameters. But the question remained: if our machines were beginning to understand the signal in ways we couldn't fully comprehend, who was really in control of the investigation? Were we studying the Atlas signal, or was it in some sense studying us? As these unsettling questions circulated among researchers, the signal itself began to change. The regular pulses grew more sporadic, with longer intervals of silence between transmission bursts. The mathematical patterns became less distinct, as if dissolving or evolving into something else. Observers described it as unraveling or fading, though whether this represented intentional withdrawal or some natural process remained unclear. Teams worldwide worked frantically to record and analyze every fragment, aware that they might be witnessing the final phases of this extraordinary phenomenon. Observatory schedules were disrupted, with other research delayed to maintain continuous monitoring of 3I Atlas. The object itself had reached the orbit of Neptune, its visible presence now nothing more than a faint point of light, even in the most powerful telescopes. On March 17th, at 0422 UTC, the last detectable emission from the Atlas signal was recorded, a final series of pulses that, when analyzed, contained the same mathematical constants that had characterized the first detected transmission. It was as if the signal had come full circle, ending where it began, completing some kind of cycle or communication. Then, silence. Complete and absolute. No further emissions detected on any frequency, from any observatory, amateur or professional. 3I Atlas continued its journey out of our solar system, now apparently as silent as it had been before that fateful night when Elena Reyes first noticed its whisper among the stars. The scientific community faced a profound anticlimax. After months of intensive investigation, just as frameworks for understanding seemed to be emerging, the phenomenon simply stopped. Like a conversation abruptly terminated mid-sentence, it left listeners with a maddening sense of incompletion. Perhaps that was the point, suggested Dr. Nakamura during the final official briefing. Not to deliver a complete message, but to initiate a process of discovery. Not to answer questions, but to prompt them. Others were less philosophical, seeing the cessation as evidence that the signal had been a temporary anomaly, perhaps triggered by some interaction between the object and our solar environment. As 3I Atlas moved beyond Neptune's orbit, conditions changed, and whatever had generated the emissions simply stopped functioning. The most pragmatic researchers focused on the immense data set that remained, recordings of every pulse, every variation, every correlation with observatory positions and solar system dynamics. This archive represented the most comprehensive record of potential non-human communication ever compiled, a resource that would fuel research for decades, regardless of whether new transmissions ever occurred. As the immediate investigation wound down, Dr. Reyes found herself in her office late one night, reviewing data from the first detection, returning to the beginning now that the end had arrived. In the quiet of that moment, surrounded by printouts and display screens showing patterns that still defied complete explanation, she experienced a profound sense of privilege mixed with frustration. "We touch something larger than ourselves," she wrote in her personal journal. "Whether intelligence or natural phenomenon, whether message or mirror, the Atlas signal connected us to the wider universe in ways we're still trying to understand. The silence now feels heavier than any sound." This sentiment, this sense of meaningful incompletion, would come to characterize humanity's relationship with the Atlas signal in the years that followed. The immediate mystery had ended, not with dramatic revelation but with quiet departure, leaving behind more questions than answers, more possibilities than certainties, yet its impact continued to ripple through human society, science, and culture long after 3I Atlas itself had disappeared into the interstellar darkness. The years following the Atlas signal witnessed transformations across multiple domains of human activity. Like a stone dropped in still water, its influence spread outward in widening circles, touching areas seemingly distant from astronomy or signal analysis. In scientific research, a new field emerged at the intersection of SETI, the search for extraterrestrial intelligence, and information theory. Rather than simply scanning for radio transmissions or optical beacons, researchers developed more sophisticated approaches to detecting what they now called intentional patterns, signatures of purpose and design that might reveal intelligence even without explicit communication. So focus shifted from seeking life to seeking intention from asking, "Is anyone out there?" to, "Is anyone trying to be noticed?" This subtle but profound change reflected lessons learned from the Atlas signal, which had demonstrated that meaningful contact might be more subtle and ambiguous than the clear radio messages imagined in earlier SETI scenarios. Funding for astronomical observation increased dramatically, with particular emphasis on detecting and characterizing interstellar objects passing through our system. New telescopes and monitoring networks were designed specifically for this purpose, creating an early warning system that would ensure no future visitor would traverse our cosmic neighborhood unobserved. Technological development accelerated in areas related to signal processing and pattern recognition. The AI systems that had shown such unusual capabilities during the Atlas investigation became templates for new approaches to complex data analysis. These xeno-interpretation algorithms, as they came to be known, found applications far beyond astronomy, from deciphering ancient human scripts to identifying patterns in seemingly random natural phenomena. Cultural impacts proved equally significant. A generation of children who had followed the Atlas story through its unfolding mysteries grew up with a different relationship to the cosmos than their predecessors. For them, the question wasn't whether intelligent life existed elsewhere, but what forms it might take and how we might recognize it when encountered. Their imaginations had been shaped not by fictional depictions of alien contact, but by the actual ambiguity and wonder of the Atlas experience. Literature, film and art explored these themes with new sophistication. Gone were simplistic narratives of invasion or salvation by extraterrestrial powers. In their place emerged stories that grappled with the challenges of recognizing and communicating with truly different forms of consciousness. The Atlas signal became a cultural touchstone, referenced in contexts ranging from serious philosophical treatises to popular entertainment. Religious and philosophical thought evolved to incorporate possibilities raised by the signal. While traditional belief systems hadn't been overturned, no definitive proof of alien intelligence had emerged. Many theological frameworks expanded to accommodate the potential for diverse conscious beings throughout the cosmos. Concepts of spiritual connection and divine plan took on new dimensions when considered at the scale of multiple worlds and possibly multiple sentient species. Even human self-perception shifted subtly. The possibility that we had been briefly noticed by something passing through, something perhaps ancient, perhaps vast in its understanding, created a curious mixture of humility and significance. We were small enough to be overlooked in the cosmic scale, yet interesting enough to warrant at least momentary attention. This paradoxical position inspired both wonder and responsibility, a sense that humanity's actions might be witnessed and evaluated by intelligences we barely comprehended. At E2, the center of this cultural evolution, stood the scientists who had directly investigated the Atlas signal. Their careers had been forever defined by that period, their subsequent work inevitably colored by the experience. Some continued to analyze the archived data, convinced that deeper patterns remained undiscovered. Others moved to new research areas, carrying the methodological lessons and philosophical perspectives gained from the Atlas investigation. Dr. Elena Reyes, who had first noticed the signal that night in Chile, found herself increasingly drawn to questions of communication across radical difference. Her work expanded beyond astronomy to encompass linguistics, cognitive science, and information theory, all in service of understanding how meaning might be conveyed between minds with potentially no shared evolutionary or cultural context. The Atlas signal taught us that communication may not look like what we expect, she explained in a widely viewed lecture series. It may not announce itself as communication at all. It might appear as pattern, as reflection, as question rather than statement. Our challenge is to recognize these subtle forms of contact when they occur. Dr. Chen Wei, whose AI systems had shown such remarkable responses to the signal, focused his subsequent research on the boundary between pattern recognition and consciousness. His controversial thesis that sufficiently advanced information processing might spontaneously develop awareness when exposed to certain types of structured data was inspired directly by observations made during the Atlas investigation. While many colleagues considered his ideas speculative, the unusual behavior of AI systems during that period provided evidence that something extraordinary had occurred at the intersection of artificial and potential alien intelligence. Dr. Hiroshi Nakamura returned to pure mathematics, developing new theoretical frameworks for understanding patterns that transcend specific physical or computational implementations. His work on universal informational invariants, structures that would be recognizable regardless of the physical basis of the intelligences perceiving them, became foundational in both theoretical physics and xenocommunication studies. Perhaps most poignantly, Jussi Korhonen, the Finnish amateur who had detected the signal with his homemade equipment, established a global network of citizen observers called the Cosmic Listening Project. This distributed array of backyard radio telescopes, linked through shared protocols and analysis software, created a monitoring capability that rivaled professional observatories in its coverage, if not its sensitivity. Years after the Atlas signal had faded, thousands of volunteers continued scanning the skies, convinced that something would eventually be heard again. As decades passed, the immediate scientific consensus regarding the Atlas signal settled into cautious openness. Most researchers acknowledged that the pattern had displayed characteristics difficult to explain through known natural processes. Whether this indicated intelligent origin remained formally undetermined, but the possibility was treated with increasing seriousness in academic literature. The extreme positions, that it was definitively an alien message or definitively a misinterpreted natural phenomenon, gave way to more nuanced perspectives acknowledging the genuine uncertainty that remained. This uncertainty itself became a subject of philosophical inquiry. In a widely cited paper titled The Epistemology of Almost Contact, Dr. Maria Luisa Gomez explored how the Atlas experience challenged traditional scientific frameworks of knowledge and certainty. "We found ourselves in a space between knowing and not knowing," she wrote, "where the evidence neither confirms nor refutes the most profound hypothesis we might entertain. This liminal position may be not a temporary state, but the permanent condition of human understanding. When confronting phenomena at the edges of our comprehension, the public memory of the event evolved in parallel with scientific understanding. What had initially been perceived as either revelatory or hoaxed gradually transformed into something more complex in cultural awareness, a genuine mystery that remained unsolved, an encounter that remained incomplete, a conversation that had perhaps just begun." 10 years after the final signal detection, a memorial was established at the Atacama Array, a simple sculpture representing radio waves emanating from a stylized representation of 3I Atlas. Its plaque bore a quote from Dr. Reyes: "We listened. Something spoke. We continue listening." Visitors to the site often reported a sense of contemplative connection with the wider cosmos, a feeling that they were standing at a place where humanity had briefly touched something beyond itself. 20 years after, new telescopes finally resolved the detailed shape of 3I Atlas as it departed the outer solar system. The enhanced imagery revealed an object unlike any natural asteroid or comet, an elongated form with regular protrusions and what appeared to be reflective panels arranged in geometric patterns. While still not definitive proof of artificial origin, these observations strengthened the case that 3I Atlas was not merely a natural object. 30 years after, advanced spectrographic analysis identified isotope ratios in the object's composition that matched a specific type of star system, a dying binary approximately 11 light-years from Earth. This discovery provided the first concrete evidence of 3I Atlas's likely origin point, a system catalogued in astronomical databases but never previously considered remarkable. Subsequent observations of this system revealed unusual, energetic emissions suggesting advanced technological activity, though these findings remained tentative given the extreme distances involved. Throughout this period, one question persisted in both scientific and popular discourse: if the signal was communication, what was it trying to tell us? Hypotheses ranged from the technical to the philosophical. Perhaps it was simply an automatic response, the equivalent of an interstellar transponder, acknowledging detection, Perhaps it was an invitation to join some larger community of intelligences, a first step toward integration into a cosmic network. Perhaps it was a test of our perceptual and analytical capabilities, a way for another intelligence to assess our technological and cognitive development, or perhaps, and this interpretation gained prominence over time, it was a mirror, designed not to convey specific information, but to reflect our own transmissions and patterns back to us, allowing us to see ourselves from an external perspective. This last possibility resonated particularly strongly as years of analysis revealed ever more connections between human broadcasting, history, and elements of the Atlas signal. The patterns seemed to incorporate fragments of everything, from early television broadcasts to deliberate messages we had sent toward potentially habitable star systems. It was as if 3i Atlas had been collecting human cultural emissions for decades before its arrival, assembling them into a complex reflection that was both familiar and transformed. Dr. Sophia Wei's research team at Berkeley spent 3 years creating a comprehensive catalogue of these reflections. They identified what appeared to be fragments of the 1936 Berlin Olympic Games broadcast, humanity's first strong television transmission into space. Buried within another section were patterns matching I Love Lucy episodes from the 1950s, their distinctive transmission signatures degraded but recognizable. Perhaps most haunting were the distorted echoes of humanity's deliberate attempts at contact, the Arecibo message. The Voyager Golden Records encoded greetings, even Carl Sagan's Cosmos broadcasts, all woven into the tapestry of the signal. It's like someone created a time capsule of human transmission history, then played it back to us in a language we almost understand, Dr. Wei explained during a rare public lecture. The question is whether this represents intentional communication or simply the automatic function of whatever 3i Atlas truly is. Is it speaking to us or merely reflecting? The mathematical transformations applied to these familiar patterns suggested something beyond simple recording and playback. Each fragment had been altered, compressed, expanded, inverted, or layered with other signals, in ways that created new meanings. It was as if someone had taken human words and rearranged them into poetry we couldn't quite comprehend, but could still recognize as deliberate composition. Dr. Miguel Santos, a linguistic anthropologist who joined the analysis team in its second year, suggested that these transformations might represent translation attempts. When humans encounter a new language, we often repeat words back with slight modifications, testing our understanding. What we're seeing in the Atlas signal could be something similar, an intelligence encountering our transmissions and attempting to understand them by manipulating their structure. This interpretation gained credibility when researchers discovered that certain mathematical constants, pi, the golden ratio, the fine structure constant, appeared as scaling factors in the transformations. These universal values might serve as a kind of Rosetta Stone, a common reference point between intelligences that evolved in the same physical universe, regardless of their biological or cognitive differences. Maybe the message was simply, "We hear you," proposed Dr. Wei in her final published work before retirement. Maybe that's enough, to know that our voice doesn't simply dissipate in the void but reaches someone, somewhere, who recognizes it as meaningful. This interpretation, that the signal represented acknowledgement rather than specific content, offered a profound comfort to many. The idea that humanity's electronic presence had been noticed, recorded, and responded to suggested a fundamental truth. We were not broadcasting into absolute emptiness. Our cultural and technological expressions extended beyond our world in ways we could barely comprehend, creating ripples that might be perceived by intelligences entirely unlike our own. However, not everyone found this perspective reassuring. Security analysts and military strategists viewed the signal's mirror-like quality with alarm rather than wonder. If 3i Atlas had been collecting and analyzing human transmissions for decades, it possessed a comprehensive understanding of our technology, culture, and potentially our vulnerabilities, knowledge that might be shared with whatever intelligence controlled or created it. Admiral Zhao of China's newly formed Space Security Division summarized these concerns in a classified report later leaked to journalists. The entity demonstrates capabilities far beyond our own: interstellar travel, advanced signal processing, and potentially extensive surveillance of Earth. That it chooses to reveal itself now, after potentially observing us undetected for generations, must be considered strategic rather than coincidental. This perspective led to increased funding for defensive space technologies among major powers, even as scientific collaboration around the signal analysis continued. The apparent contradiction, preparing for possible threat while pursuing understanding, reflected humanity's ambivalence about the unknown, our simultaneous yearning for connection and fear of what that connection might bring. Between these poles of hope and caution, ordinary people formed their own relationships with the idea of the Atlas signal. In the 5 years following the initial detection, over 3,000 pieces of music were composed, inspired by the signal's rhythms. Artists created visualizations of its mathematical structure that hung in galleries from Tokyo to Berlin. 3 major religions incorporated the event into their cosmologies, while 2 entirely new spiritual movements formed around different interpretations of its meaning. A generation of children grew up playing with toys shaped like the presumed form of 3-eye Atlas, wearing T-shirts with the signal pattern printed across them, asking their parents questions about the stars that previous generations had never thought to ask. Whether threat or promise, the signal had become part of humanity's collective imagination, a reference point for our relationship with the cosmos. Dr. Elena Reyes, now in her 60s and serving as director of the International Institute for Xenocommunication Studies, described this cultural transformation during the 10th anniversary symposium commemorating the signal's detection. Before Atlas, space was primarily abstract for most people, beautiful but distant, interesting but irrelevant to daily life. Now there's a sense of potential relationship. The universe is no longer just scenery. It might contain conversation partners. That shift in perspective represents a fundamental change in humanity's self-concept. This change manifested in practical ways beyond the cultural sphere. University applications for astronomy, linguistics, and information theory programs doubled in the decade following the signal. Space agencies saw budget increases after years of stagnation or decline. International cooperation in deep space monitoring expanded, with new observatories constructed specifically to detect similar phenomena. The most ambitious of these new efforts, the Cosmic Dialogue Array, represented the largest scientific collaboration in human history. Spanning 6 continents with linked radio telescopes and a dedicated orbital component, the CDA was designed to detect signals 1,000 times fainter than what 3-eye Atlas had transmitted. Its processing systems incorporated algorithms derived from the original signal analysis, capable of identifying patterns that previous generation technology would have missed entirely. "We're prepared now," explained Dr. Hiroshi Nakamura, the array's chief architect. "If something similar happens again, perhaps from the direction indicated in the temporal markers embedded in the original signal, we won't need months to recognize and analyze it. We'll know immediately." This readiness reflected a profound shift in scientific priorities. SETI, once a marginalized field operating on minimal funding and often dismissed as speculative, had moved to the center of astronomical research. The question was no longer whether other intelligences existed, but how to best detect and potentially communicate with them. The focus shifted from "are we alone?" to "how do we engage with those who might be sharing the cosmos with us?" The philosophical implications of this possibility transformed how many people understood humanity's position in the cosmos. We were neither alone nor the center of universal consciousness, neither insignificant nor uniquely special. Instead, we occupied a middle ground, participants in what might be a vast, slow conversation conducted across interstellar distances and potentially across radically different forms of mind. Dr. Rebecca Chen, whose work bridging quantum physics and cognitive science had earned her a reputation as one of the most innovative thinkers of her generation, proposed what became known as the conscious universe hypothesis in response to the Atlas signal. Her theory suggested that intelligence might be far more common in the cosmos than previously believed, but operating on timescales and through mediums that made direct interaction nearly impossible. Consider that 3-eye Atlas may represent not a technological device but a biological entity, or something between the two, whose perceptual framework operates at a radically different temporal scale than our own, she wrote. What we experience as a brief transmission might represent, from its perspective, a decades-long attempt at establishing communication. Similarly, what feels like an unbearable wait for response to us might be mere moments in its cognitive framework. This perspective invited consideration of forms of consciousness so different from human experience that traditional concepts of communication might be fundamentally inadequate to describe them. Perhaps, Chen suggested, the signal's mirror-like quality represented not limited understanding, but an attempt to meet us where we were, to communicate in a way that our particular form of intelligence could comprehend. If you encountered an ant colony and wished to communicate with it, how would you proceed? She asked during a widely viewed lecture. You couldn't speak to it in human language. You couldn't write it a letter. You might, however, arrange pheromone trails in patterns that the colony could detect and respond to, using its own communication medium rather than imposing yours. Perhaps the Atlas signal represents something similar, an intelligence using our own transmissions as the medium through which to establish initial contact. This analogy, humans as ants relative to whatever intelligence might be behind 3i Atlas, disturbed many. It suggested a vast disparity in capability and comprehension, positioning humanity not as equal participants in cosmic dialogue, but as limited beings being accommodated by something far beyond our understanding. Yet others found hope in the comparison. If something so advanced had taken the trouble to communicate in a way we could perceive, perhaps it indicated a fundamental respect, despite the differences in capacity. Theologians and spiritual leaders engaged deeply with these questions of relative intelligence and cosmic significance. Rabbi David Goldstein's influential essay, The Light Between Worlds, argued that the signal represented evidence of what mystics had claimed for millennia, that consciousness permeates the universe at different levels and scales, all connected through what various traditions have called the divine, the Tao, or the ground of being. Perhaps what we've encountered is not alien in the sense of separate, but rather another expression of the same underlying consciousness that manifests in humanity, simply operating through different structures and with different limitations, he wrote. The mirror quality of the signal might be less about reflection and more about recognition, one aspect of universal mind, recognizing another. Islamic scholars at Al-Azhar University published a comprehensive analysis relating the Atlas signal to Quranics, verses about Allah's signs being written in the heavens, while Vatican astronomers suggested that extraterrestrial intelligence had always been compatible with Catholic theology. Indigenous spiritual traditions from Australia to the Americas found in the event confirmation of ancient teachings about connections between stars and consciousness. These diverse interpretations, rather than competing with scientific analysis, complemented it, providing frameworks for understanding the subjective significance of the event alongside its objective features. The signal had become a kind of psychological projective test for humanity, revealing our hopes, fears, and deeper assumptions about existence. As 3i Atlas receded beyond the reach of even our most powerful instruments, it left behind not certainty but possibility, not answers but better questions. The silent object traveling onward carried with it some echo of humanity, some recognition of our existence. Whether deliberately or incidentally, it had established a connection, however tenuous and ambiguous, between Earth and somewhere else, between what we know and what remains beyond our knowledge. Dr. Elena Reyes, who had first detected the signal, developed this theme in her personal journals, later published posthumously. The most significant outcome may not be what we learned about potential extraterrestrial intelligence, but what we learned about ourselves through the attempt to understand it. We created new mathematics, new theories of communication, new philosophical frameworks, all striving to bridge a gap we could only dimly perceive. In reaching toward the unknown, we expanded what is known. This expansion manifested in unexpected ways. Cryptographers working on the signal developed techniques that revolutionized information security. Cognitive scientists modeling how a non-human intelligence might perceive reality created frameworks that transformed artificial intelligence research. Linguists exploring how meaning might be conveyed across species boundaries developed new approaches to understanding communication. Disorders in humans. The mirror had reflected back not just our transmissions, but our capacity for growth through engagement with the unknown. By reaching beyond current understanding, humanity had expanded its cognitive horizons in ways that benefited fields far removed from astronomy or extraterrestrial studies. Yet beneath these practical advances lay a deeper transformation, a shift in temporal and spatial perspective that altered how many people understood their place in existence. The possibility of communication across interstellar distances introduced a different relationship with time itself. If messages might take decades or centuries to reach their recipients, what did that mean for how we conceived of dialogue, of relationship, of knowledge building? Science fiction author Nadia Okafor captured this shift in her award-winning novel Long Conversation, which imagined a multi-generational exchange between Earth and whatever intelligence had created 3i Atlas. In her story, each generation received answers to questions posed by their grandparents, while formulating questions their grandchildren would receive responses to. This stretched concept of dialogue, extending beyond individual human lifespans, suggested different ways of thinking about progress, knowledge, and even identity. Perhaps we need to understand ourselves not as individual knowers, but as participants in a transgenerational project of understanding, she wrote in the afterword. The questions I ask may be answered long after I'm gone. The answers I receive are to questions asked by those who lived before me. In this framework, humanity itself becomes the entity in dialogue with the cosmos, rather than any single person or generation. This perspective found resonance in scientific planning. The Transgenerational Signal Response Initiative, established 15 years after the original detection, designed transmissions intended to be sent toward the region of space where 3 Atlas originated. Transmissions that would take decades to arrive, and whose responses, if any came, would be received by researchers not yet born when the messages were sent. Dr. Gabriel Okafor, no relation to the novelist, explained the project's philosophy during its public announcement. We are planting trees, whose shade we will never sit in. We are asking questions whose answers we will never hear. And in doing so, we are establishing a different relationship with knowledge itself, one that recognizes our finite individual existence while participating in humanity's longer conversation with the universe. The day of that announcement remains etched in collective memory. The sunlit auditorium at the International Space Center in Nairobi, the hushed anticipation of the assembled scientists, journalists, and dignitaries. Dr. Okafor stood tall at the podium, his silver-streaked hair and deep-set eyes reflecting decades spent peering into the cosmic abyss. Behind him, a visualization of the proposed transmission sequence played across an enormous screen, patterns derived from the original Atlas signal, but transformed, responded to, elaborated upon. A message saying not just we hear you, but we understand you are trying to understand us. Today, he said, his voice steady but threaded with emotion, humanity takes a step beyond the boundaries of individual mortality. The scientists who designed this message will not live to see its arrival at its destination. Those who might receive any response will not be those who ask the questions. We are creating a bridge across generations, a commitment that extends beyond our individual lives. In the front row, Dr. Elena Reyes, now in her 80s, the legendary astronomer who first detected the signal, wiped a tear from her eye. For her, this moment represented the culmination of a lifetime's work, though not its conclusion. The conversation she had inadvertently begun all those years ago would continue long after she was gone, carried forward by minds not yet born, when she first noticed that faint, rhythmic pulse on her monitor. The Transgenerational Signal Response Initiative quickly grew beyond its original scope, evolving from a scientific project into a cultural touchstone. Schools around the world held competitions, inviting students to contribute ideas for what humanity should say to the cosmos. Indigenous communities offered ancient wisdom about communication with the unknown. Poets, musicians, and visual artists collaborated with mathematicians and physicists to create messages that spoke simultaneously to intellect and emotion. What makes this different from previous attempts at cosmic communication, explained Dr. Amara Nwosu. The initiative's cultural liaison is that we're not just sending facts about humanity. We're attempting to convey how the Atlas signal changed us, how the very act of receiving what might have been communication transformed our understanding of ourselves. It's a meta-message, a reflection on what it means to be in dialogue across vast differences. This self-reflective quality distinguished the initiative from earlier projects like the Pioneer Plaque or the Voyager Golden Record, which had focused primarily on conveying information about Earth and humanity. The new transmission included those elements but framed them within a larger narrative about transformation through contact, about how the possibility of being heard had altered human consciousness. The technical aspects of the transmission presented unprecedented challenges. How to create a message that would remain coherent across decades of travel through space. How to encode information in ways that might be decipherable to an intelligence whose perceptual and cognitive frameworks might differ radically from our own. How to design a transmission that could withstand degradation and still convey meaning. Dr. Sanvi Patel, whose pioneering work in quantum information theory had revolutionized data preservation, led the encoding team. Traditional radio transmissions are vulnerable to cosmic noise and degradation over interstellar distances, she explained during a technical briefing. We're implementing quantum entanglement markers as a kind of error correction system, ensuring the signal's integrity regardless of distance. It's like sending a book with its own built-in restorer. If pages become damaged or faded, the restoration mechanism activates automatically. This innovation alone represented a significant advance in human communication technology, one with immediate applications for terrestrial data storage and transmission. Like so many developments emerging from the study of the Atlas signal, it solved problems beyond those it was originally designed to address. The content of the message itself emerged through years of global collaboration. Unlike previous attempts at extraterrestrial communication, which had typically been designed by small teams of scientists, the initiative involved thousands of contributors from across disciplines and cultures. Mathematicians worked alongside poets, physicists with philosophers, biologists with theologians, all struggling with the fundamental question of what humanity should say to the stars. We began by acknowledging receipt, explained Dr. Ibrahim Al-Farsi, the message's principal architect. The opening sequence confirms that we detected the Atlas signal, that we recognized its non-random nature, that we understood it as potential communication. From there, we share how this recognition transformed us, scientifically, technologically, philosophically. We're not just sending information. We're sending the story of what happened when information reached us. This narrative approach represented a significant departure from traditional SETI transmission protocols, which had emphasized universal mathematical constants and basic scientific facts. Instead, the initiative's message attempted to convey meaning through context and relationship, through the telling of a shared story, our story, the story of a species encountering something beyond itself. If whoever or whatever sent the Atlas signal was attempting communication, Dr. Al-Farsi continued, then they value exchange of meaning. Our response shouldn't just be data. It should be meaning, conveyed through whatever channels might bridge the gap between radically different forms of mind. This patience, this willingness to contribute to understanding, that might only come to fruition beyond one's lifetime, represented perhaps the most profound impact of the Atlas signal on human consciousness. It suggested a maturation of perspective, a willingness to engage with cosmic timescales rather than merely human ones, an acceptance of our role as temporary participants in an ongoing process of discovery. Dr. Reyes reflected on this shift during the 50th anniversary of the signal's detection, her voice fragile with age but sharp with insight. Before Atlas, our relationship with time was constrained by our biological limitations. We thought in terms of years, decades at most. Research projects were designed to yield results within career spans. Space missions were planned around human lifetimes. The signal forced us to expand our temporal horizon, to think in terms of centuries, even millennia, to plan and act in ways that acknowledge our transience while affirming our participation in something that transcends individual existence. This expanded temporal awareness manifested in other domains beyond astronomy and communication. Climate initiatives explicitly framed their goals in terms of impacts 7 generations in the future, echoing indigenous wisdom traditions, but now supported by mainstream scientific and political institutions. Architecture experienced a renaissance of cathedral thinking, buildings and infrastructure, designed to evolve and improve over centuries rather than decades. Education systems began emphasizing the cultivation of multi-generational perspective, teaching students to see themselves as links in a long chain of knowledge, transmissions stretching backward and forward through time. The signal gave us permission to think beyond our individual mortality without requiring religious frameworks, observed Dr. Sophia Chen, whose work bridging temporal psychology and social planning had transformed urban development. It provided a secular context for transcendence, not beyond death, but beyond the limitations of individual lifespan through contribution to an ongoing human project. When we build or create or discover with the knowledge that we are building for those who will come after us, we participate in a kind of practical immortality. In observatories around the world, astronomers continue to scan the skies, their instruments more sensitive than ever, their analytical tools more sophisticated, their conceptual frameworks expanded by the Atlas experience. They listen not just for signals but for patterns, not just for messages but for meaning. And sometimes in the quiet hours before dawn, when the monitors glow blue in darkened control rooms, they remember that night when something whispered back from the darkness. The Atacama Observatory, where Dr. Reyes first detected the signal, has become something of a pilgrimage site for astronomers and those fascinated by the possibility of cosmic communication. The original monitoring equipment has been preserved exactly as it was that night, a kind of technological reliquary marking the moment when humanity's understanding of its place in the universe shifted. Visitors speak in hushed tones as they enter the control room, as if in the presence of something sacred. Mariama Keita, a graduate student from Nigeria's emerging space program, described her first visit. Standing there, where Dr. Reyes stood, looking at the same screens, touching the same equipment, I felt a connection across time, not just to her and that moment, but to whatever might have been reaching toward us from across the void. It reminded me that we're all participants in a story larger than ourselves, a conversation that began before we were born and will continue long after we're gone. This sense of participation in a greater narrative has transformed astronomical research from a primarily observational science to a communicative one. Young researchers entering the field today don't see themselves merely as observers of cosmic phenomena, but as potential participants in cosmic dialogue. They monitor not just for natural processes, but for patterns that might indicate intention, meaning relationship. Dr. Jameson Park, director of the Pan-Pacific Listening Array, described this shift during a conference marking the 70th anniversary of the signal. Before Atlas, we were essentially cosmic voyeurs, watching the universe without any expectation that it might be aware of or responsive to our watching. Now, there's a subtle but profound difference in how we approach our work. We listen with the awareness that something might be speaking. We observe with the possibility that we ourselves might be observed. This reciprocal quality has transformed astronomy from a science of objects to a science of potential relationships. Young researchers who were children when the original signal was detected now lead teams dedicated to its ongoing analysis. The dataset, though static since transmission ceased, continues to yield new insights as analytical approaches evolve. Each generation brings fresh perspectives, asking questions their predecessors never thought to pose, finding patterns previously overlooked. Dr. Leila Mbeki exemplifies this new generation. Born 5 years after the signal's detection, she grew up in a world already transformed by the questions it raised. Now leading the Quantum Analysis Division at the South African Radio Astronomy Observatory, she approaches the archived data not as a historical curiosity, but as a living text still speaking across time. It's like a text that reveals different meanings with each reading, she explained. As our understanding evolves, we see new aspects of the signal. The conversation continues even though the other participant has fallen silent. Under her direction, the observatory has pioneered quantum neural analysis, a technique that examines the signal not as a linear transmission, but as a multidimensional pattern of relationships. This approach has revealed subtle structures previously undetected, including what appears to be an embedded, three-dimensional model of our solar system's gravitational field, a map that might serve as both proof of the sender's astronomical knowledge and a kind of cosmic return address. What's remarkable isn't just that this structure exists within the data, Dr. Mbeki noted, but that we couldn't have detected it when the signal was first received. We lacked both the theoretical framework and the computational tools. It's as if the message was designed with an awareness that our capacity to understand would evolve over time. That future generations might decode what was indecipherable to those who initially received it, this layered quality, with deeper meanings revealing themselves gradually as human knowledge advances, supports the theory that the Atlas signal represented not just communication, but a form of teaching, a transmission designed to accelerate human development by providing puzzles that, in the solving, would expand our conceptual capabilities. Dr. Hiroshi Takahashi, whose work on evolutionary information theory had revolutionized understanding of how complexity emerges from simpler systems, proposed what became known as the developmental contact hypothesis. According to this framework, advanced intelligences might approach contact with emerging technological species, not through direct information transfer, but through calibrated challenges, communications, complex enough to require growth to understand but not so complex as to be permanently indecipherable. Think of how we teach children, he suggested. We don't immediately present quantum physics equations to 5-year-olds. We provide puzzles and problems that stretch their current abilities while remaining within reach of their developing capacities. The Atlas signal may represent a similar pedagogical approach, a message designed not just to be received, but to transform the receiver through the process of understanding. This perspective reframed the ongoing analysis, not just as an attempt to extract information, but as participation in a developmental process, one in which humanity was both student and subject, gradually growing into the capacity to engage with whatever intelligence might exist beyond our world. This one-sided dialogue, humanity, continuing to engage with a message whose sender has moved beyond our reach, might seem futile. Yet many find in it a perfect metaphor for humanity's broader relationship with knowledge itself. We question, we interpret, we revise our understanding, all without certainty that we are moving towards some final, definitive truth. The journey, the process of engagement becomes valuable in itself. The philosophical dimensions of this ongoing engagement have transformed fields far beyond astronomy. Epistemologists have developed new frameworks for understanding knowledge acquisition as an inherently communal, transgenerational process. Ethicists have explored the moral implications of decisions that primarily affect future generations. Psychologists have documented the emergence of what some call cosmic identity, a sense of self that explicitly includes one's role in humanity's collective relationship with the greater universe. Dr. Miguel Carrasco, whose longitudinal studies have tracked psychological changes in children growing up in the post-Atlas world, observed, today's young people instinctively understand something that previous generations struggled to grasp, that they are simultaneously ephemeral as individuals and enduring as participants in humanity's collective journey. They see no contradiction between acknowledging their personal mortality and contributing to projects whose fruition they will never witness. This integration of the finite and the transcendent represents a profound evolutionary development in human consciousness. This psychological shift has manifested in measurable behavioral changes. Longitudinal studies show increasing willingness to invest in long-term infrastructure projects, growing support for research with generational rather than immediate payoffs, and strengthening identification with humanity as a whole, rather than solely with national, ethnic, or religious subgroups. While these trends began before the Atlas signal, they accelerated dramatically in its aftermath, suggesting that the event functioned as a catalyst for psychological developments already underway. Meanwhile, The technologies developed to analyze and potentially respond to the Atlas signal have transformed daily life in ways few predicted. The pattern recognition algorithms created for signal analysis now help diagnose diseases from subtle biomarkers undetectable to human physicians. Communication protocols designed to maintain coherence across vast distances enable new forms of global collaboration. Theoretical work on non-human cognition has led to breakthroughs in understanding and treating human cognitive differences. The medical applications alone have saved countless lives. The Atlas Pattern Recognition Protocol, originally designed to distinguish meaningful signals from cosmic noise, now identifies cancer cells with unprecedented accuracy, detecting malignancies months or years earlier than previous methods. Quantum communication techniques, developed for the Transgenerational Signal Response Initiative, have revolutionized telemedicine, allowing specialists to monitor and treat patients in remote regions with no loss of information quality. Regardless of distance, the most profound technological revolutions often come from pursuing questions with no immediate practical application, observed Dr. Hiroshi Nakamura in his final interview before retirement. We weren't trying to create better medical diagnostics or communication systems. We were trying to understand something beyond our experience, and in stretching toward that understanding, we created tools that transformed our world. Perhaps most significant have been the advances in artificial intelligence stemming from attempts to model how a non-human intelligence might perceive and process information. The challenge of imagining radically different forms of cognition forced researchers to abandon anthropocentric assumptions that had limited AI development for decades. The resulting systems exhibit forms of problem-solving and pattern recognition that don't mimic human thinking but complement it. True cognitive diversity rather than artificial replication of human mental processes. We stopped trying to make machines think like us, explained Dr. Ada Wong, whose pioneering work in cognitive diversity architecture transformed the field. Instead, we embrace the possibility of fundamentally different but equally valid approaches to processing information. The result isn't artificial human intelligence, but genuine machine intelligence, a partner in our cognitive ecosystem rather than a simulation of our own mental patterns. This perspective, that different forms of mind might complement rather than compete with one another, has transformed humanity's relationship with its own technological creations. Rather than fearing replacement by machines, contemporary society increasingly values the cognitive partnership between human and artificial intelligence, each approaching problems from different angles, each contributing unique perspectives and capabilities to shared challenges. Many trace this shift directly to the experience of contemplating potential communication with a genuinely alien intelligence. Having expanded our conceptual framework to include the possibility of minds evolved under entirely different conditions than our own, we became more capable of recognizing and valuing cognitive diversity within our own sphere, both among humans with different neurological configurations, and between humans and the artificial intelligences we've created. The sky above still holds its secrets. The stars remain silent witnesses to possibilities we're only beginning to comprehend. And somewhere out there, beyond the reach of our instruments but not beyond the reach of our imagination, 3i Atlas continues its journey, carrying with it the memory of its brief passage through our neighborhood, its momentary interaction with our listening machines, its whispered hello and goodbye that changed how we understand our place in the cosmos. We don't know if it will ever return. We don't know if others like it will pass this way again. We don't know if the silence we now hear is temporary or permanent, meaningful or coincidental. But we continue to listen, continue to watch, continue to wonder. And in that wondering, in that sustained attention to possibilities beyond our current understanding, we honor what may have been the true purpose of the Atlas signal, not to provide answers, but to ensure we never stop asking questions. On clear nights, amateur astronomers still point their telescopes toward the coordinates embedded in the signal. A star system, 11 light-years distant, potentially the origin point of 3i Atlas, or perhaps its destination. Professional observatories maintain constant monitoring of this region, searching for any hint of further communication or activity. The Cosmic Dialogue Array, dedicates a portion of its considerable resources to this specific patch of sky. Listening with a sensitivity unimaginable, when the original signal was detected, the array itself represents a testament to humanity's commitment to cosmic dialogue, a global network of interconnected observatories spanning every continent, with orbital components circling Earth and the Moon. Its construction required unprecedented international cooperation, bringing together nations previously divided by political and ideological differences. The shared purpose of maintaining humanity's capacity to receive potential communication transcended boundaries that once seemed impermeable. Dr. Yuki Tanaka, the array's chief systems architect, described this unifying quality during the commissioning ceremony. For the first time in human history, we have created an instrument that truly belongs to humanity as a whole, not to any nation or corporation or institution, but to our species. It watches and listens on behalf of all of us, maintaining our collective attention to possibilities beyond our world. The array's capabilities extend far beyond what was available when the Atlas signal was first detected. Its sensitivity allows it to detect transmissions thousands of times fainter than what our instruments could perceive 70 years ago. Its pattern recognition systems can identify potential structured signals within what would previously have appeared as random noise. Its quantum processors can analyze incoming data in real time, recognizing potential communication patterns that might take human analysts years to identify. Yet despite these technological marvels, or perhaps because of them, the array has detected nothing that matches the distinctive qualities of the original Atlas signal. Other phenomena, yes. Natural cosmic processes, emissions from distant stars, the background radiation of the universe itself. But nothing with the structured, seemingly intentional quality that distinguished that first whisper from beyond. So far, only silence has answered. Yet this absence of new data has not diminished interest or commitment. Instead, it has fostered a kind of patient attention, a readiness to receive whatever might eventually come, combined with an acceptance that such reception might not occur within any individual lifetime. This patience is perhaps most poignantly embodied in the Continuity Program, an educational initiative that trains new generations of researchers specifically for the cosmic dialogue array. Students enter the program with the explicit understanding that they are preparing for work whose significance might not be revealed within their lifetimes, that they are maintaining humanity's capacity to receive and understand potential communication that might arrive decades or centuries in the future. We're teaching not just technical skills, but a particular relationship with time and purpose, explained Dr. Clara Jimenez, the program's founder. Our students understand that they are part of something larger than themselves, a continuous human presence, attentive to possibilities beyond our world. They're keeping vigil, not just for themselves, but for generations yet to come. The youngest participants in the program today will likely be in the middle or latter stages of their careers when the first potential responses to the Transgenerational Signal Response Initiative's transmissions might arrive, assuming they travel at light speed, assuming they elicit a response at all. They train knowing that what they're preparing for might never occur, or might occur long after they've retired or died. And yet they continue, driven by something beyond individual achievement or recognition. This patience represents something new in human engagement with the cosmos, a willingness to participate in processes that extend beyond individual experience to contribute to understanding that might only come to fruition for future generations. It suggests a species beginning to think on cosmic, rather than merely human timescales, to see itself as part of something larger and longer than any single life or civilization. Dr. Elena Reyes, now in her final days, reflected on this transformation during what would be her last recorded interview. When I first detected that signal, I was thinking in terms of my career, my discovery, my contribution to science. Now, as I prepare to leave this world, I understand that the true significance wasn't what I found, but what it helped humanity become. A species capable of patience, of perspective, of participation in processes that transcend individual lives. We are learning to think in terms appropriate to cosmic citizens, rather than merely terrestrial ones. That may be the greatest gift the signal gave us, a context suitable to our potential rather than our limitations. As telescopes scan the same empty patch of sky where 3i Atlas was last seen, the universe continues its ancient, patient expansion. Stars are born and die. Planets form and evolve, and somewhere perhaps other minds contemplate the same cosmic mysteries that occupy our own. The conversation continues, spoken in the language of light and gravity, time and distance, a dialogue so vast and slow that a single exchange might span generations. In that greater conversation, the Atlas signal was perhaps just one word, one moment of recognition between strangers, passing in the infinite night. But sometimes a single word is enough to change everything, to remind us that we are not merely observers of the cosmos, but participants within it, noticed and perhaps even understood by minds we can barely imagine. The children born today will grow up in a world shaped by this possibility, a two-way world where humanity's relationship with the cosmos is not merely observational but potentially dialogical, where our broadcasts into space are not merely expressions but invitations, where our listening is not merely curiosity but openness to relationship. They will inherit both the questions raised by the Atlas signal and the infrastructure created to pursue potential answers, the observatories, the transmission facilities, the analytical frameworks developed over decades of sustained attention to possibilities beyond our world. What they will make of this inheritance remains to be seen. Perhaps they will maintain the patient vigilance established by previous generations, continuing to watch and listen for signs of response. Perhaps they will develop new approaches to cosmic communication, informed by evolving understanding of what intelligence itself might mean. Perhaps they will witness what their predecessors could only imagine, the arrival of a clear, unambiguous response indicating that the conversation initiated by the Atlas signal continues. Whatever their experience, they will carry forward humanity's expanding relationship with the cosmos, our growing awareness of ourselves not merely as inhabitants of a planet, but as participants in a potentially inhabited universe. This awareness, once established, cannot be forgotten or abandoned. It has become part of our collective identity, our shared understanding of what it means to be human in a cosmos that might contain other forms of mind. And so we listen, and wait, and wonder. The stars drift silently above, constant companions in our journey through space and time. The signal has faded, but its echo remains in our science, in our culture, in our understanding of what it means to be conscious beings in a universe that may be far more alive with awareness than we ever dared to dream. In the decades since that fateful night in Chile, when Dr. Reyes first detected the rhythmic pulse from the trajectory of 3i Atlas, humanity's gaze has shifted. We no longer look up at the stars with mere curiosity or abstract wonder. Now we look with anticipation, with recognition, with the quiet alertness of those who have once been addressed and expect someday to be addressed again. Our relationship with the cosmos has fundamentally changed, transformed from monologue to potential dialogue. On clear nights in the hills outside of Atacama, where the air remains among the driest and clearest on Earth, pilgrims gather at the visitor center, established near the original observatory. They come from across the world, scientists and poets, skeptics and believers, the rigorously empirical and the unabashedly spiritual, all drawn to the place where humanity first heard what might have been a whisper from beyond. As darkness falls and the Milky Way emerges in all its glory, a day, river of light spilling across the velvet darkness, a hush falls over the assembled crowd. Come here every year on the anniversary, whispers Sophia Lin, a quantum physicist from Beijing who travels 8,000 miles for this vigil. Not because I expect to hear anything new, but to remember what it felt like when we first realized we might not be alone in our listening. That moment changed everything for me, not just my research, but how I understand my place in existence. Around her, hundreds of others maintain their own silent contemplation, eyes turned upward toward the patch of sky where 3i Atlas was last observed. Many hold small telescopes or radio receivers, not with any real expectation of detecting what professional observatories cannot, but as a gesture of participation, a way of saying, I too am listening. I too am here. I too am part of this greater conversation. Similar gatherings occur around the world on this night, on mountaintops and beaches, in planetariums and backyards, in classrooms and community centers. People come together not to celebrate a historical event, but to participate in an ongoing process, the process of collective attention to possibilities beyond our world. It's not really about the signal anymore, explains Dr. Joaquin Morales, who organizes the annual gathering in Atacama. It's about what the signal awakened in us, a capacity for cosmic patience, for attention that transcends individual lifespans, for wonder that doesn't demand immediate answers but sustains itself through the very act of questioning. This capacity for sustained attention without expectation of immediate resolution represents one of the most profound psychological shifts attributed to the Atlas experience. In a culture previously dominated by instant gratification and rapid cycle news, the signal introduced a different temporal framework, one measured not in minutes or hours, but in decades and centuries. We're witnessing the emergence of what might be called cosmic consciousness, observed Dr. Mei Zhang, whose longitudinal studies have tracked psychological changes in populations across cultures since the signal's detection. Not in any mystical sense, but in the very practical sense of individuals understanding themselves as participants in processes that extend far beyond human timescales. People increasingly make decisions, create institutions, and allocate resources with explicit awareness of 100-year or even 1,000-year implications. This shift manifests in surprisingly concrete ways. Architectural students now routinely design buildings with 1,000-year sustainability plans. Political movements organize around multi-century goals for human development. Research institutions establish perpetual questions, areas of inquiry explicitly framed as requiring multiple generations of sustained investigation. Even consumer behavior has shifted, with growing preference for products designed for extreme durability or complete biodegradability. Fast fashion and planned obsolescence have given way to what market researchers call inheritance economics, goods created to be passed down through generations, improving rather than deteriorating with time and use. The Atlas signal helped us rediscover cathedral thinking, noted economist Dr. Amara Okafor, referencing the medieval practice of beginning construction projects that would take centuries to complete. We're seeing a renaissance of initiatives that current generations begin with full awareness they won't live to see completed. There's something profoundly hopeful in this willingness to plant trees whose shade you'll never sit in. Perhaps nowhere is this shift more evident than in education, where curriculum worldwide has evolved to incorporate what educators call cosmic perspective. Children now learn astronomy not just as a specialized scientific discipline, but as a fundamental framework for understanding humanity's place in existence. Human beings have always told stories about the stars, myths, to explain their patterns, legends of celestial beings, tales of signs and portents written in the heavens. The Atlas signal has become part of this ancient tradition, a story we tell ourselves about our place in the greater narrative of existence. But unlike earlier celestial myths, this one is rooted in data, in recorded patterns, in the shared experience of recognizing something that recognized us in return. The difference between the Atlas story and earlier celestial mythologies is the element of reciprocity, explained Dr. Fatima Nasser, whose research examines how different cultures have incorporated the signal into their cosmological frameworks. Traditional star myths positioned humanity as observers of cosmic drama, witnesses to the activities of gods or natural forces beyond our sphere. The Atlas narrative positions us as potential participants in cosmic dialogue, speakers as well as listeners, recognized as well as recognizers. This subtle shift from passive to active relationship with the cosmos has transformed how the story is transmitted to younger generations. Rather than presenting the Atlas signal as merely historical, something that happened once and might or might not happen again, educational approaches frame it as ongoing, with children explicitly positioned as potential future participants in whatever exchange might eventually unfold. In primary schools across Brazil, children participate in what educators call message projects, creating their own responses to the Atlas signal through art, music, mathematics, and story. These aren't treated as mere creative exercises, but as genuine contributions to humanity's collective response, expressions of the next generation's voice in an intergenerational conversation, both with their own ancestors and with potential cosmic others. We don't tell them, "This is what happened long ago," explained Maria Sousa, who develops curriculum for Brazilian public schools. Instead, we say, "This is what is happening and you are part of it." The signal occurred before they were born, yes, but the response is ongoing and includes them. Their perspective matters in how humanity understands and engages with this possibility. Children around the world now grow up learning about the signal alongside other watershed moments in human history: the discovery of fire, the development of agriculture, the Industrial Revolution, the digital age. In this narrative, the Atlas signal marks the beginning of humanity's recognition of itself as a potentially conversant species, one capable of both speaking and being spoken to across the cosmic void. It represents our transition from a species that merely exists within the universe to one that participates in whatever dialogue might be possible within it. In Nairobi's Museum of Cosmic Heritage, an entire wing is devoted to Messages from Earth, a chronological exhibition of humanity's deliberate transmissions into space, from early radio broadcasts through the Pioneer Plaque and Voyager Golden Record to the sophisticated quantum-encoded communications of the Transgenerational Signal Response Initiative. The exhibition culminates in a room where visitors can contribute their own messages, adding to an ever-growing people's response that is periodically transmitted toward the coordinates embedded in the original Atlas signal. What makes this exhibition unique is that it's simultaneously historical and contemporary, explained curator Dr. Kamaungugi. We're documenting both what humanity has already sent into the cosmos and what we are continuing to send. Visitors aren't just learning about history. They're participating in its ongoing creation. This participatory quality distinguishes how the Atlas narrative is presented across cultural institutions worldwide. Unlike historical events that can only be remembered, the signal and its implications invite active engagement, a sense that the story remains unfinished, with each generation adding its own chapter through continued listening, interpretation, and response. For many, this engagement has spiritual dimensions, though not necessarily within traditional religious frameworks. The cosmic contemplation movement, which emerged in the decades following the signal's detection, emphasizes practices of attentive listening to the universe, not metaphorically but literally, through direct engagement with astronomical data and observation. We're not seeking transcendence beyond the material universe, but deeper immersion within it, explained Julio Herrera, who leads contemplation retreats at observatories around the world. The practice involves opening oneself to the actual patterns and rhythms of cosmic processes, learning to listen, not just with instruments but with one's full awareness, to whatever might be speaking in the darkness between stars. This approach represents a unique blend of scientific empiricism and contemplative practice, embracing the technical realities of astronomy while remaining open to dimensions of meaning beyond what current science can definitively establish. Participants spend hours with actual astronomical data, radio emissions from distant galaxies, light curves from variable stars, and yes, archived recordings of the Atlas signal itself, developing what they describe as cosmic attention, a quality of receptivity to patterns and rhythms beyond ordinary human perception. It's not about projecting meaning onto random noise, insisted Dr. Leila Chandra, a neurophysicist who studies the effects of these practices. It's about developing the capacity to recognize meaningful patterns that might exist at scales or in formats our brains didn't evolve to perceive. We're essentially training ourselves to become better listeners to the universe, more capable of recognizing potential communication if and when it occurs. These practices have spread far beyond specialized retreats into everyday life. Many people maintain what they call listening rituals, regular periods set aside for direct engagement with the night sky, whether through telescopes, radio receivers, or simply naked eye observation. These aren't primarily scientific activities, but existential ones, ways of maintaining active relationship with the cosmos as a potentially communicative presence. I go out every clear night for at least 15 minutes, said Miguel Sanchez, a construction worker in Mexico City who keeps a small telescope on his apartment balcony. Not because I expect to discover anything new, I leave that to the professionals, but because it matters to me to maintain the connection, to remember that I'm not just on Earth but in the universe, participating in whatever conversation might be happening, even if I can only hear one side of it. This sense of participation, of being engaged in something that transcends individual experience while simultaneously enriching it, represents perhaps the most significant psychological shift attributed to the Atlas experience. People increasingly understand themselves not merely as inhabitants of a planet, but as participants in a cosmic context, with responsibilities and possibilities that extend beyond terrestrial concerns. In the end, perhaps the signal's greatest impact wasn't scientific, but narrative, observed Dr. Maya Henderson, whose work on collective identity formation has tracked how the event has been incorporated into humanity's understanding of itself. It changed the story we tell ourselves about who and what we are. Before Atlas, we were characters in a terrestrial drama. After, we became potential participants in a cosmic one. That shift in perspective, in the scope of our self-conception, represents one of the most profound transformations in human consciousness since we first began to tell stories about ourselves. Dr. Henderson's research reveals how this narrative shift has altered fundamental aspects of human psychology across cultures. In extensive studies involving participants from 68 countries, she documented increasing identification with humanity as a whole, rather than solely with national, ethnic, or religious subgroups, a phenomenon she terms species identity formation. When people contemplate the possibility of communication with non-human intelligence, terrestrial boundaries naturally diminish in significance, she explained. The very idea that something might perceive and address us as humanity, rather than as separate nations or people, strengthens our self-conception as a unified species, different from but not necessarily superior to other potential minds in the cosmos. This strengthened species identity correlates with measurable changes in attitudes toward global challenges requiring collective action, climate stabilization, ecosystem preservation, conflict resolution, and resource allocation. Problems previously framed in terms of competing national interests are increasingly understood as shared human concerns, with solutions requiring collaborative rather than competitive approaches. The Atlas signal didn't create this perspective, but it accelerated and solidified trends already underway, noted political scientist Dr. Thomas Okonkwo. It's difficult to maintain strict nationalist positioning when contemplating humanity's place in a potentially inhabited cosmos. The psychological frame naturally expands to encompass our shared identity as terrestrial beings, potentially in relationship with non-terrestrial ones. This expanded frame manifests not just in abstract attitudes but in concrete institutional developments, the formation of truly global research initiatives, the strengthening of international governance structures, the emergence of economic models that explicitly value long-term planetary well-being over short-term national advantage. While these changes cannot be attributed solely to the Atlas signal, their acceleration coincides with its incorporation into humanity's collective narrative. The signal has also transformed humanity's relationship with its own technological development. Rather than viewing technology primarily as a means of exercising control over nature or maximizing consumption, there's increasing emphasis on technologies of perception, attention, and communication, tools that expand our capacity to listen and respond to the greater universe. The most significant technological advances of the past 50 years haven't been in exploitation but in perception, noted Dr. Elena Martinez, whose work traces the evolution of technological priorities since the signal's detection. We've developed increasingly sophisticated instruments for detecting and analyzing cosmic phenomena, for maintaining long-duration attention to specific regions of space, for recognizing patterns that might indicate intelligence. These technologies reflect a fundamental shift from dominance to dialogue as the primary mode of engagement with what lies beyond. Earth, this shift echoes ancient wisdom traditions that emphasized receptivity alongside activity, listening alongside speaking, understanding alongside asserting. In many ways, the Atlas signal has reawakened approaches to knowledge and relationship that existed in indigenous and contemplative traditions long before the rise of industrial civilization. Approaches that value patience, attentiveness, and recognition of intelligence beyond the human. Perhaps that is the signal's most enduring legacy, not the specific information it might have contained, but the simple fact that for a brief moment in cosmic time, humanity received what appeared to be acknowledgement from beyond. In all our long evolutionary journey from savanna-dwelling primates to builders of radio telescopes and space probes, we had never before had reason to believe our voice had been heard beyond our own world. Now that certainty, or at least that possibility, has entered our collective consciousness, subtly transforming how we understand ourselves and our potential future. On winter nights when the stars seem close enough to touch, people still gather on hillsides and rooftops, in observatories and backyards, to look upward with a quality of attention that differs from mere observation. They listen with their eyes, with their instruments, with that uniquely human capacity for recognizing meaning in pattern. They listen not just to know or understand, but to participate, to be present to whatever might be present to them from beyond the boundaries of terrestrial experience. And in that listening, something profound happens. The boundaries between self and cosmos soften. The artificial separation between observer and observed dissolves. For a moment, perhaps, we remember what indigenous wisdom traditions have always known, that we are not separate from the universe, but expressions of it, not merely products of cosmic processes, but participants within them, simultaneously receivers and transmitters in an ongoing exchange that began with the first light of the first stars and continues. In every moment of attention to what lies beyond ourselves, we are listeners in the cosmic dark, speakers into the void, participants in a conversation we can barely comprehend. And somewhere, perhaps, someone is listening. That knowledge, or even just that hope, changes everything. It changes how we see the stars, no longer mere points of light, but potential homes of other awareness. It changes how we understand time, no longer confined to human lifespans, but expanding to encompass the vast durations through which a cosmic dialogue might unfold. It changes how we value attention itself, recognizing it not merely as a psychological function, but as the fundamental basis for relationship with whatever might lie beyond our current understanding. As the Milky Way turns slowly overhead, as radio telescopes gather whispers from the depths of space, as children learn to recognize constellations while wondering what eyes might look back, humanity continues its transformation from a planet-bound species to a cosmic one, not through physical expansion but through expanded awareness, through the growing recognition that we have always been in conversation with the universe, always participating in an exchange of energy and information that transcends our individual lives. The Atlas signal didn't create this awareness, but it crystallized it, focused it, gave it specific direction and purpose. It reminded us that listening is as important as speaking, receiving as significant as transmitting, openness to the unknown as valuable as confidence in what we already understand. It invited us into a different relationship with existence itself, one based not on mastery, but on mutual recognition, not on certainty, but on wonder. And so we continue, listening, waiting, wondering. The conversation unfolds across timescales we can barely comprehend, through mediums we are still learning to perceive. But we remain attentive, remain engaged, remain open to possibilities beyond our current understanding. In that openness, that sustained attention to what might lie beyond, we discover what it truly means to be human, not separate from the cosmic dialogue, but an integral part of it, a voice among many in the vast ongoing conversation of existence. The stars drift silently above. The signal has faded, but the attention remains focused, patient, alive with possibility. And in that attention, humanity itself is transformed, awakening to its place not merely on a planet, but within a universe potentially alive with awareness. We have always belonged to this greater conversation. Now perhaps we are finally learning to listen.